Hello students. In this video we are going to study about the theorems on limit points. We have seen the limit points. Now we are going to study about the theorems which uses the concept limit point. So the one famous theorem, that is Bolzano-Weistrass theorem. So let's see the definition statement for Bolzano-Weistrass theorem, and we'll see first for sets. We are not going to discuss any of the results for sets in this chapter. We are mainly focusing on sequence and series especially. So it is very necessary to the Bolzano-Weistrass theorem for sets. So what is the statement? We see the statement first. Every infinite bounded set has a limit point. This is the statement of the theorem. Every infinite bounded set has a limit point. We have seen what is a limit point. In the previous video we have gone through the definition of a limit point. So suppose you have a infinite set. It has a limit point. So now see the definition, theorem for sequence. This is an important theorem. We are going to prove the theorem, the Bolzano-Weistrass theorem. Now we are going to study for this is a sequence theorem, important theorem. So every bounded sequence we are talking about here, we used infinite bounded sequence, but your every bounded sequence has a limit point. This is a statement. Every bounded sequence. How we are deciding whether the sequence is bounded or not? We are looking into the range set. We are mainly talking about the range set. Based on a range, we are deciding whether the sequence is bounded above or bounded below, right? So now, so it is necessary to see this theorem for sets is important. So because your set, the bounded sequence, your range of this is a set basically. You are talking about the bounded of a sequence based on their range. So here a range is just a set. It's an infinite set or maybe a finite set. So it is necessary to go through this theorem first, that every infinite bounded, so it's a bounded set, every infinite bounded set has a limit point. Every infinite bounded set has a limit point. Okay, it's so let's see your bounded, maybe it is your bounded sequence having a range maybe finite or infinite. Okay, let's see the proof. Let Sn be a bounded sequence, because we are talking about the bounded sequence. We have to choose a bounded sequence, and let S be a range. Its range. Why you have to choose a range? Because we are talking about the boundedness of a sequence based on its range. So let us represent the range set by, that is S is equal to an such that n belongs to n, right? Set of natural numbers. We have seen the definition of sequence. Okay. Since Sn is bounded, since the sequence Sn is bounded, so S is also bounded. And go through the examples of a bounded sequence and see the ranges. So think this one. why it is need to be bounded. I left you to think on this. Okay, so we'll take a case one, that your range set, it may be finite or may be infinite. This set may be finite. We have two cases here. This set may be finite or infinite, okay. You have seen the examples, right? Range set is finite or infinite. Okay, let S be like for the first case we'll discussing on of a finite case. Let S be a finite set. Let S be a finite set. Let's see what's going to happen in a finite set. So then there exists a number L such that Sn is equal to L. Sn is equal to L for an infinite values, for an infinite number of values of n belongs to n. Okay, so see, suppose in your range set there exists a one number such that Sn is equal to L. Such an S may be any real number for an infinite number of values of n. Okay, let me take to understand this thing, let me take one small example here. Let me take a constant sequence. Sn is equal to 5. It's a constant sequence. You take S1 is equal to 5, S2 is equal to 5. This is for all n belongs to n, right? The constant sequence. S3, the S3 is also 5, S4 is also 5, so on. You take any values of n, you will get the same value, right? That means your range is, what is the range set? Range set is 5. It is finite. It is finite. It is finite, right? The range of the sequence is 5 and it is finite. See the meaning. There exists a number L. See, that is this is a number L such that Sn is equal to L. See, this is Sn is equal to L. Consistency for an infinite number of values of n belongs to n. See, infinite number of values of n. See, 1, 2, 3. For any values of n you take, you will get 5 only. That number L only. See, this is L only you are getting. The meaning of this statement, what I have written here, the meaning of statement is this. Suppose your n take so for infinite values of you will get the same value. Your L is 5 only. Take another example. Sn is equal to 1 plus minus 1 to the power n. The range set is 0 and 2 only, right? For infinite values of n, you are getting the range as 0 and 2 only. Range set is 2, 0 and 2 only. That means so this implies given epsilon greater than 0, an belongs to, not an, Sn, this is, sorry, Sn belongs to L minus epsilon comma L plus epsilon, right? That's the meaning of this statement. The meaning of this statement I'm writing. You have seen Sn is equal to L in the limit point discussion. So yeah, I can write this as Sn belongs to L minus epsilon, L plus epsilon for an infinite values of n. So that means your Sn belongs to L minus epsilon and L plus epsilon. And so that is this. The meaning of this is every neighborhood of L. The meaning of this is every neighborhood of L contains infinitely many terms of the sequence. Infinitely many terms of the sequence Sn. So the meaning of this, we have seen what is neighborhood. So the meaning of this is this. Okay, that means what is that? Then L is a limit point. Then L is a limit point. Limit point of the sequence Sn. The very simple proof of the theorem. If Sn, your range set is finite, your range set is finite. Suppose, let me take the case 2. What is the case 2? Your range set is infinite. Suppose let S be an infinite set. S be an infinite set. S be an infinite set. What happens? So since S is an infinite bounded set, because your sequence is in bounded sequence, so if sequence is bounded, then the range set has to be bounded. Suppose your Sn is a bounded sequence, then S is an infinite bounded sequence. Bounded sequence. Sorry, it's not a bounded sequence, bounded set. Okay, this is not bounded sequence, this is bounded set. Okay, then so we have seen the result by Weistrass. Bolzano-Weistrass theorem. By Bolzano-Weistrass theorem for sets, it is said that S has at least one limit point. Has a limit point, it is given that means it has at least one limit point. At least one limit point. Let us say L. We have seen that your set may have more than one limit point. So now L is a limit point of S. So this implies that every neighborhood of L contains, by the definition of limit point, an infinite number of terms of S, right? Number of terms of S. But your S, each element of S, is a term of the what? Is a term of your sequence, right? Is a term of the sequence Sn. Is a term of the sequence Sn. That means L contains an infinite number of terms of right, then our element of but each element of S is a term of is an element, not term, I'll say element of the sequence, right? Each element of ನೀವು ತಗೊಳ್ಳುವಂಥ ಸೆಟ್ಟಿನ ರೇಂಜ್ ಸೆಟ್ಟಲ್ಲಿ ಏನಾಗ್ತದೆ ಅದೆಲ್ಲ ಎಸ್ ಎನ್ ಇನ ಟರ್ಮ್ಸ್ಗಳಲ್ವಾ. ಸೊ ದಟ್ ಮೀನ್ಸ್ ಎವ್ರಿ ನೇಬರ್ಹುಡ್ ಆಫ್ ಎಲ್, ದಿಸ್ ಮೀನ್ಸ್ ವಾಟ್? ಎವ್ರಿ ನೇಬರ್ಹುಡ್ ಆಫ್ L contains infinite number of terms of the sequence Sn. Infinite number of terms of the Sn. What does it mean? Then L is a limit point of the sequence. So ಈ ರೀತಿಯಾದ ಇನ್ಫೈನೈಟ್ ನಂಬರ್ ಆಫ್ ಟರ್ಮ್ಸ್ ಕಂಟೈನ್ ಮಾಡಿದರೆ ಸೀಕ್ವೆನ್ಸ್ ಇದು ಎಲ್ ಏನಾಗಿರ್ತದೆ, ಎಲ್ ಹೇಗಿರ್ತದೆ? ಎಲ್ ಬಿಲಾಂಗ್ಸ್ ಟು ಇಲ್ಲಿ Sn belongs to L minus epsilon, L plus epsilon, right? So Sn ಇದರ ಈ ಓಪನ್ ಸೆಟ್ಟಿನ ಒಳಗಿರ್ತದೆ, L ಅನ್ನು ಕಂಟೈನ್ ಆಗಿರುವಂಥದ್ದು. ಸೊ ದಟ್ ಮೀನ್ಸ್ L is a limit point of the sequence. So simple theorem and very important theorem. ಇದು ಕೂಡ. Okay, let's see the one more theorem. So the next theorem is that the set of the limit points of a bounded sequence has the greatest and the least members. Of course, proof is not included in the syllabus, so you have to study the statement of the theorem. So ನಿಮಗೆ ಸೆಟ್ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್ಗಳ ಸೆಟ್ ಏನಿರ್ತದೆ, ಸೊ ಅದರಲ್ಲಿ ಗ್ರೇಟೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಮತ್ತು ಲೀಸ್ಟ್ ಮೆಂಬರ್ಸ್ಗಳು ಇರ್ತದೆ. So for example, Sn is equal to now 1 plus minus 1 to the power n. What is the limit point? Limit points ಏನಾಗಿರ್ತದೆ? 0 ಮತ್ತು 2 ಅಲ್ವಾ? What is the least value? ಇಲ್ಲಿ least value ಏನಾಗಿರ್ತದೆ? 0 is the least member and 2 is the greatest number. Simple one. Okay, now moving to the next topic is limit superior and limit inferior of a sequence. Limit superior and limit inferior of a sequence. Limit superior and limit inferior of a sequence. Okay, let's see the definitions. Okay, let Sn be a bounded sequence, then the sequence has the least and the greatest limit points. Just ಈಗಷ್ಟೇ ನಾವು ನೋಡಿದೆವು ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ. ಸೊ ಅದರಲ್ಲಿರುವಂಥ ಲೀಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಅನ್ನು the least limit point of Sn is called the limit inferior. The limit inferior ಅಂತ ಹೇಳ್ತೇವೆ, or inferior limit or lower limit of Sn ಅಂತ ಕರೀತೇವೆ, sequence Sn, and ಇದನ್ನು denoted by ಒಂದು notation ಕೊಡ್ತೇವೆ. It is denoted by limit n tending to infinity infimum of Sn. infimum ಅಂತ infimum ಅಂತ ಹೇಳ್ತೇವೆ. ಲಿಮಿಟ್ ಸುಪೀರಿಯರ್, ಲಿಮಿಟ್ infimum of Sn ಅಂತ ಹೇಳ್ತೇವೆ. ಅದೇ ರೀತಿ ದ ಗ್ರೇಟೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂವಿಗೆ ದ ಗ್ರೇಟೆಸ್ಟ್ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್ ಆಫ್ Sn is called the limit superior or supremum ಅಂತವೂ ಹೇಳ್ತೇವೆ. limit superior or superior limit or upper limit ಹೇಳ್ತೇವೆ, and it is denoted by limit n tending to infinity supremum of Sn. Is a notation form. Okay. So based on this observation, let us see some, based on this definition, let us see some observations. ಏನು ಹೇಳ್ತದೆ, suppose if his Sn is unbounded above, suppose Sn is unbounded above, and it is bounded below but bound above ಇರುವುದಿಲ್ಲ, unbounded above. So we write ಏನಾಗಿರ್ತದೆ ಅವಾಗ, ಸುಪ್ರೀಮಮ್ ಇರೋದಿಲ್ಲ, ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಅಂತ ಹೇಳಿ ಇರೋದಿಲ್ಲ. ಲಿಮಿಟ್ ಎಸ್ n tending to infinity, supremum of Sn is equal to infinity. Suppose this is unbounded below, Sn is unbounded below, we write limit n tending to infinity, infimum of Sn is equal to minus infinity. Infimum of Sn is minus infinity. Okay. Let's see the examples. So let's take the sequence Sn is equal to examples. Sn is equal to minus 1 to the power n. Only the limit points are minus 1 and plus 1, right? Minus 1 and plus 1. So the limit points which is bounded, right? The set minus 1, 1 ಮತ್ತು ಇದು ಬೌಂಡೆಡ್. ನಾವು ಯಾವಾಗ ಮಾತಾಡೋದು ಬೌಂಡೆಡ್ ಸೀಕ್ವೆನ್ಸಿಗೆ ಮಾತ್ರ, ಲಿಮಿಟ್ ಇನ್ಫಿಮಮ್ ಮತ್ತು ಲಿಮಿಟ್ ಸುಪ್ರೀಮಮ್. ಸೊ ಏನು ಬರಿಬೋದು ಇಲ್ಲಿ, ಲಿಮಿಟ್ ಇನ್ಫಿಮಮ್ ಆಫ್ Sn as n tending to infinity, that is equal to smallest value is minus 1, and limit n tending to infinity supremum of Sn is equal to 1. ಸರಿ, ಅದೇ ರೀತಿ ಇನ್ನೊಂದು ಡೆಫಿನೇಷನ್, ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡ್ರೆ Sn is equal to 1 by n, that is 0 is the only one limit point. ಸೊ ಇದು ಮ್ಯಾಕ್ಸಿಮಮು ಅದೇ, ಮಿನಿಮಮ್ಮು ಅದೇ. ಸೊ ಅಂಥ ಕೇಸ್ಗಳಲ್ಲಿ ನಾವು ಹೇಗೆ ಬರೀತೇವೆ, ಲಿಮಿಟ್ n tending to infinity supremum of Sn which is equal to 0 and also equal to limit n tending to infinity infimum of Sn. ಎರಡು ಸೇಮ್ ಆಗಿರ್ತದೆ, ರೈಟ್? ಓಕೆ, ಒನ್ ಮೋರ್ ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಳೋದಾದರೆ, Sn is equal to 1 plus minus 1 to the power n. ಸೊ ತುಂಬ ಫೇಮಸ್ ಎಕ್ಸಾಂಪಲ್, ನಮಗೆ ತುಂಬ ಸಲ 2-3 ಸಲ ನಾವು ಎಕ್ಸಾಂಪಲ್ ಅಂತ ತಗೊಂಡಿದ್ದೇವೆ ಸೀಕ್ವೆನ್ಸನ್ನು. ಸೊ ಇಲ್ಲಿ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್ಸ್ ಆರ್ ಯಾವುದೆಲ್ಲ, ಓನ್ಲಿ ದ 0 ಆ್ಯಂಡ್ 2 ಮಾತ್ರ. ಸೊ ಇದರಲ್ಲಿ ಲೋವರ್ ಲಿಮಿಟ್ ಯಾವುದು, ಅಥವಾ ಇನ್ಫಿಮಮ್ ಲಿಮಿಟ್ ಆರ್ ಇನ್ಫೀರಿಯರ್ ಲಿಮಿಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 0. ದೆನ್ ದ ಅಪ್ಪರ್ ಲಿಮಿಟ್, supremum limit or superior limit, that is equal to 2. Okay. Next, Sn is equal to n square ತಗೊಂಡ್ರೆ ಏನಿದೆ, n ಸ್ಕ್ವೇರ್ ತಗೊಂಡ್ರೆ ಏನಾಗ್ತದೆ, ಇಲ್ಲಿ ಇದರ ರೇಂಜ್ ಸೆಟ್ ಏನಾಗಿರ್ತದೆ, ಸೊ 1, 4, 9, 16, so so on 25 not sorry so 25 so on continue ಆಗ್ತದೆ. It is bounded below, right? Bounded below, right? The sequence is bounded below but not above, not above. ಒಂದಿಗಿಂತ ಎಲ್ಲ ವ್ಯಾಲ್ಯೂ ಇದೆ. ಸೊ it has, but also it has no real limit, has no real limit. ಇದಕ್ಕೆ ಲಿಮಿಟ್ ಅಂತದ್ದು ಇಲ್ಲ. ಚೆಕ್ ಮಾಡಿ ಯಾಕೆ has no real limit point, not limit, it has a limit point ಇಲ್ಲ. ಥಿಂಕ್ ಯಾಕೆ ಅಂತ ಹೇಳಿ. ಗೋ ಟು ದ ಡೆಫಿನೇಷನ್ ಆಫ್ ಎ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್. ಅಲ್ಲಿ ಏನೆಲ್ಲ ಆಗ್ತದೆ ಅಂತೇಳಿ ನೋಡಿ, ಜಸ್ಟ್ ಥಿಂಕ್ ಮಾಡಿ ಯಾಕೆ ಇದಕ್ಕೆ ರಿಯಲ್ ಲಿಮಿಟ್ ಇಲ್ಲ ಅಂತೇಳಿ. ಸೊ ಇನ್ಫೈನೈಟ್ಲಿ ಮೆನಿ ನೇಬರ್ಹುಡ್ ಸಿಗ್ತಾ ಇದೆಯಾ ಅಂತೇಳಿ ನೋಡಿ, ಕಂಟೈನ್ ಮಾಡುವಂಥ ನೇಬರ್ಹುಡ್ ಸಿಗ್ತಾ ಇದೆಯಾ ಅಂತೇಳಿ. ಓಪನ್ ಸೆಟ್ ತಗೊಂಡು ಅದರಲ್ಲಿರೋ ಪಾಯಿಂಟ್ಸಿಗೆ ತುಂಬ ಏನೋ ಓಪನ್ ಇಂಟರ್ವಲಲ್ಲಿ ಎಸ್ ಎನ್ನಿನ ಟರ್ಮ್ಸ್ಗಳು ಇನ್ಫೈನೈಟ್ ಆಗಿ ಇದೆಯಾ ಅಂತೇಳಿ ನೋಡಿ. ಸೊ ಅವಾಗ ಗೊತ್ತಾಗ್ತದೆ ಇದರಲ್ಲಿ. ಸೊ ಎಸ್ ಎನ್ ಸ್ಕ್ವೇರ್ ಹ್ಯಾಸ್ ನೋ ರಿಯಲ್ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್.